Welcome to an example of an application problem involving quadratic regression using the TI-84. The table below shows the height h of t in meters of an object that is launched off the top of a building after t seconds. Use your calculator to perform quadratic regression using the data. The first step is to enter the data into the TI-84. We will enter the times in L1 and the heights in L2. To do this, from the home screen, we press Stat, Enter, and to save time, I've already entered the times in L1 and the heights in L2. Before we perform the regression though, let's create a scatter plot. To do this, we press second y equals and turn plot 1 on by pressing Enter. With the cursor blinking on, press Enter. Everything else looks good. We have the scatter plot as the type, X list is L1, Y list is L2, each point will be a small square. So if we press Graph, notice how we do not see the scatter plot because we need to adjust the window. And we can do this a couple ways. We can do it manually or we can try Zoom Fit. Let's first try Zoom Fit by pressing Zoom and then option 9. And now we have a nice scatter plot for the data. And now let's perform the quadratic regression and store the regression equation in Y1. To do this, we press Stat, right arrow once to calculate, option 5 for quad regression. X list is L1, Y list is L2. Arrow down to frequency list. We are not using a frequency list. We leave this blank. Arrow down to store regression equation. And now we will enter Y1 to automatically store the equation in Y1. To do this, we press vars, right arrow to Y vars, enter, and enter to select Y1. Down to calculate and press enter. Here we have the regression equation where A is negative 4.9, B is 33.6, and C is 76. And the equation is also automatically stored in Y1. Let's go ahead and write this equation down. Just remember, our function is h of t, where the input variable is t. So h of t is equal to negative 4.9 t squared plus 33.6t plus 76. Now let's go back to the TI-84 for a moment, and let's press Graph. Because the regression equation is stored in Y1, notice how it's automatically graphed on top of the scatter plot. And we can see the function is an excellent fit for the data. Number 2, using the regression equation from above, how high will the object be 2.8 seconds after launch? To answer the question, we need to find h of 2.8 or substitute 2.8 for t. And because we have the equation automatically stored in Y1, we can simply enter Y1 of 2.8 to determine the corresponding height. So let's go ahead and do that. Let's go to the home screen by pressing second mode for quit. Press vars, right arrow once to Y vars, enter for Y1, in parentheses, enter 2.8. To the 10th place value, the height is approximately 131.7. So after 2.8 seconds, the object will be approximately 131.7 meters high. Number 3, using the regression equation, how long will it take the object to reach a height of 17 meters? To answer this question, we would substitute 17 for h of t and then solve for t. We will answer this question graphically using the TI-84. But to do this, we do need to adjust the window. If we press window, notice the y minimum is approximately 84.6. It has to be below 17 in order for us to answer the question. So let's go ahead and adjust the window. Let's change the x min to, let's say, negative 2, enter. The x max to 10, enter. Let's leave the y scale at 1, enter. Let's change the y min to negative 20, enter. The y max to 200, enter. And let's change the y scale to 10. If this window does not look good, we can always come back and adjust it. Let's press Graph. And we have a pretty good window for the given data where y equals 17 does show on the graph. So now to find when the object reaches a height of 17 meters, we will graph y equals 17, then determine the point of intersection. To do this, press y equals, press enter down to y sub 2, enter 17, and then graph. If we determine the intersection point here on the right, we can determine how long it will take the object to reach a height of 17 meters. To find the point of intersection, press second trace for the calculation menu, option 5 for intersect. Because we only have 2 graphs on the coordinate plane, we can simply press enter 3 times. Enter, enter, enter. The ordered pair for the point of intersection appears at the bottom of the screen. At approximately 8.3 seconds, the height is 17 meters. So now we know the object will reach a height of 17 meters after approximately 8.3 seconds. And for the last question, when will the object hit the ground? We can do this 2 ways. Let's first use a similar strategy we did for number 3. So let's go back to the calculator. Let's press y equals. Let's go down to y sub 2, press clear, and let's enter y sub 2 equals 0. When the object is on the ground, the height is 0. So now if we press graph, if we determine the point of intersection here on the right, we can determine when the object will hit the ground. Again, to do this, we press second trace for the calculation menu, option 5 for intersection. Press enter 3 times. At the bottom of the screen, we can see the height is 0 at approximately 8.7 seconds. Another way to answer number 4 would be to find the horizontal intercept of the regression equation, which I also want to show. To find the horizontal intercept, we press second trace for the calculation menu, and we calculate the 0. This will give us the t-value where the height is 0. So we press 2 for 0. It's asking for left bound, so you need to be to the left of the horizontal intercept. So if I press the left arrow, notice how I am now left of the horizontal intercept, or 0. Press enter. Next it asks for the right bound, which in this case would be below the horizontal intercept. Let's say here, enter, and enter 1 more time. And notice how we do get the same x value here on the left of approximately 8.7. Notice how the y value is showing as scientific notation, which is very, very close to 0. I hope you found this helpful.